Okay, in this next set of rules, we have our trigonometric integration rules. So if you want to integrate the cosine of x, that's going to integrate to sine of x plus a constant. Now the reason we know this is because we know the derivative of sine of x is actually cosine of x. So we know that way, so if we integrate cosine of x, we should get sine of x, and then of course plus a constant. So here's an example. Let's say if you wanted to integrate 2x plus cosine x dx, then when you integrate that, you would integrate the 2x, and we know that integrates to just x squared. And then if you integrate the cosine of x, that's going to just integrate, as the rule says, to sine x, and then you have a constant to add at the end. Now, when we integrate the sine x function dx, we're going to get minus cosine x plus a constant. And the reason it's minus is because if you'll remember, the derivative of cosine x is minus sine. So therefore, if we integrate positive sine x dx, we would get minus cosine x plus a constant. So here I have 5 minus sine x dx. And to integrate that, if you integrate a constant 5, you're just going to get 5 times the variable x. And then remember, if you integrate sine x, you're going to get minus cosine x, but since there's a minus there, you're actually going to get minus a minus cosine x, which is going to be plus cosine x, and then you add your constant at the end. Now, to integrate secant squared x, we just get tangent x. Now I know this integral is going to equal tangent x because we know the derivative of tangent x is secant squared x. So therefore, if we integrate 10 secant squared x dx, that would be the same as 10 times the integral of secant squared. So that would be just 10 times tangent x plus a constant. And if you integrate secant x tangent x dx, we know that's secant x plus a constant because the derivative of secant x was given earlier as secant x tangent x. So if I integrate x squared plus secant x tangent x, well, x squared would integrate with the power rule to x cubed over 3, and then secant x tangent x using this rule would integrate to secant x. So my answer would be x cubed over 3 plus secant x plus a constant. And then if you integrate the integral cosecant squared x dx, that's going to equal minus cotangent x plus a constant. And that's because when you took the derivative of cotangent x, you got minus cosecant squared. So if you integrate cosecant squared, positive cosecant squared, you're going to get minus cotangent x plus a constant. So here I'm integrating 2 cosecant squared x dx, and that's going to integrate to 2 times the integral of cosecant squared, and the integral of cosecant squared is minus cotangent. So 2 times minus cotangent is going to be minus 2 cotangent plus a constant. And then the last one here is when you integrate cosecant x cotangent x dx, you get minus cosecant x plus a constant. And so over here, if you integrate this, you have cosecant x minus, you have cosine x minus cosecant x cotangent x. Now we know the cosine x integrates to sine x, and we know the cosecant x cotangent x integrates to cosecant x. Integrates to minus cosecant x, and then you have a minus there. And so when you put that minus with the minus cosecant x, then you're actually going to get a positive cosecant x here, and then plus a constant. Now the reason we don't have integrals, you might be wondering, well, why don't you have an integral for tangent, or an integral for cotangent, or an integral for secant by itself, or an integral for cosecant? Well, the only reason we have these formulas is because we knew the derivatives of the 6 basic trig functions. Well, since we don't know any derivatives that would actually come from the other trig functions. See, we know cosine is the derivative of sine x, and we know sine is the derivative of minus cosine x, but we don't know what function is the derivative of tangent x per se, so that's why we don't have those formulas. But we actually will get those formulas later. Okay, so now here's some examples applying the basic rules of integration here. So if you integrate 3dx, you just get 3x plus a constant. Here, if you integrate 5/4 times the square root of x cubed, that would be 5/4 times x to the 3/2 dx. And so we integrate x to the 3/2 dx using the power rule. So you get x to the 5/2 over 5/2, and you're going to multiply that times 5/4. And then when you divide by 5/2, same as multiply by 2/5. And so when you multiply this together, you actually just get a half. And then so you just get 1/2 times x to the 5/2 plus a constant. And then this one is it's a sum rule, power rule, and a trig rule. So the power rule portion is to integrate x squared, you get x cubed over 3. The sum portion is that you're integrating a sum. So we know that we would just go ahead and integrate, find the integral of cosecant squared x, which is minus cotangent x, and then plus a constant. And then here's another sum rule. And we also have some constant multiples in here because we have a multiple of 3 here and a multiple of 5 here. But we need to write square root of x as an exponent, so I can write that as x to the 1/2. And 1 over x cubed I can write as x to the -3. Now when I integrate x to the 1/2, that's going to be x to the 3/2 over 3/2 using the power rule. And then we're multiplying that by 3. That was outside the integral. And then when I integrate x to the -3, that's going to be x to the -2 over -2. And I'm multiplying that by 5. That was outside that integral. And then when you multiply 3 times 2/3, the 3's cancel, so you just get 2x to the 3/2. And then here you're going to have actually minus 5/2, because you're going to have 5 over -2, so you're going to have minus 5/2. But also in the denominator, I can move this to the denominator and change it to positive x squared, or x to the positive 2 power. And so finally I have this term minus this term plus the constant. Don't forget the constant. Here's another example, 3 sine x plus 5 secant squared x. So here we're using a couple of trig rules. If you integrate sine x, you get minus cosine x. So if you integrate this, you would get 3 times minus cosine x, which is minus 3 cosine x. And here, if you integrate this, you would get 5 times the integral of secant squared x, and the integral of secant squared x is tangent x, so that'd be 5 times tangent x, and then plus your constant. This is just another simple power rule. That's 4 times the integral of x to the 11th, so that's 4 times x to the 12th over 12, plus a constant, which is just x to the 12th over 3 plus a constant. Now, some integrals you actually need to do some manipulation. So for instance, right here on this one, I don't have a formula for integrating a function to a power. So what I'm going to do is I'm just going to FOIL this, 2x plus 5 times 2x plus 5, and get 4x squared plus 20x plus 25. And then I can integrate this term by term. So 4x squared integrates to 4x cubed over 3. 20x integrates to 20x squared over 2, which would just be 10x squared. And the constant 25 integrates to 25x. And then, of course, you add your constant. Here I can actually factor. There's a formula for factoring difference of cubes. So actually x cubed will factor into x minus 2 times x squared plus 2x plus 4. And then I can cancel x minus 2 over x minus 2. And then all I'm left with is that trinomial, and I can integrate that trinomial. So that's that. If I integrate this, I get x cubed over 3. And if I integrate 2x, I get 2x squared over 2. And then the 2's would cancel, so I just get x squared. And then when you integrate 4, you get 4x, and then don't forget your constant at the end. And then here's another little trick you can do here. This one you can since you have a difference over a single denominator here, you can always break up the numerator as long as you put the denominator in both terms. So I can rewrite this as x cubed over x squared right here minus 3 over x squared. Well, x cubed over x squared is just x, and then 3 over x squared I can write as 3 times x to the negative 2. And then if I integrate x, I get x squared over 2. And if I integrate 3x to the negative 2, well, using the power rule, if I add 1 to this, I get x to the negative 1 divided by negative 1. And then when you take negative 3 and divide it by negative 1, you actually get a plus. And then since this would have been 3 times x to the negative 1, I can move the x to the negative 1 to the denominator and just make it x to the positive 1. And then just add the constant at the end. Now, down here are some practice problems if you want to practice on these. The top portion is the problem, and then the answer is the bottom portion of each of these. So there's the problem on top and the answer on the bottom. There's the problem on top, the answer on bottom, and the problem on top and the answer on bottom. So if you want to work those in your spare time and see if you get the same answer as I do, feel free to do so. Now, I mentioned a minute ago that we didn't have a rule that would allow me to integrate functions raised to a power. We only have the rule for the simple power rule, which is for when you just have a single variable raised to a power. But in some situations, you can integrate a function using a power rule, but the function's got to work out just right for it to work. And so I'll talk about that when I talk about the general power rule in the next video.